possible equations that we could use for examples that we use a circuit similar to this, which is a common emitter without an RE, which is resistance at the emitter, between the emitter of the transistor to the ground. So the first thing probably that we need to evaluate will be the currents going through or out of the transistor. Usually, for an NPN transistor of this nature, you would have a current IB going into the base. You would have a current IC going into the collector, and you would have a current IE coming out of the emitter of the transistor, thus establishing this relationship. So if we had a node right here, and you had a current coming in, current coming out, this happens to be IC, this happens to be IB, and this happens to be IE, then we can apply Kirchhoff's law to the node here, where let's say the ones coming in are positive and the one going out is negative, and the sum of all of this will be 0. So in other words, we would have IC as a positive value plus IB minus IE equals 0. So that would be the basic relationship established through this node if we apply Kirchhoff's law for current. So with this, we can extract a few relationships that would be very useful. So let's keep that aside, and let's look at now voltage relationships based on the fact that the voltage drop between the emitter and the base is always 0.7 volt, but for this time we're going to call it VBE. Now, when I say always, it's almost 0.7 volts if the transistor is made of silicon. Okay, so the junction that's between the N and the P here will yield 0.7 volts if the transistor is operating. So, well, this is interesting because this basically says that at this point here versus ground, this voltage from here to here is VBE. So we can establish the relationship also, what is the voltage from here to here and here. Well, we know this one. By knowing this one, we can actually extract the current that goes through RB. And the current that goes through RB happens to be the same as IB. Okay? So let's establish that equation on the side here. So basically, we're doing Kirchhoff's law for voltages. And that would be something like this. RB, IB, plus VBE minus VCC equals 0. Again, this is applying Kirchhoff's law of voltages on this end. So can we establish a few things here? Can we find, for example, what is IB out of this equation? And the answer is absolutely. So we can actually move everything to the side. So we would have RBIB equals VCC minus VBE. Okay. Can we now extract IB? Absolutely. And that would be VCC minus VBE divided by RB. So now we've got the current IB at least right here, okay, in relation to these quantities, VCC, VBE, and RB. Excellent. Now let's go and look at this side and apply Kirchhoff's law based on the fact that we also have a voltage called VCE, and we also have voltage drop against RC, which yields the current IC. Okay, well, let's go ahead and apply Kirchhoff's law here. So we know that IC, RC, plus VCE minus VCC equals 0. Excellent. Can we extract IC out of this? Sure. So same thing we've done with IB. So we can go ahead and do ICRC equals VCC minus VCE. And then IC equals VCC minus VCE divided by RC. Okay. Now that we've extracted IC and extracted IB, can we relate these two together? And yes, for all transistors, IC is equal to beta IB. So this is a fundamental equation here where beta is the DC current gain for the transistor. So knowing that, can we substitute either side with either this or this, depending on what we're looking for? Okay? And so, for example, let's say we want to find IC based on beta, then we could do IC beta times VCC minus VBE over RB. So this is one way to find IC. Okay, so we have an IC equation here based on this side of the circuit, but we can also find IC based on this side of the circuit. Okay, can we do something with IB? Oh, yeah, sure. So if you wanted to find something with IB, we also know that that would be IC over beta, and then substitute your IC for this value, for example, and that would be VCC minus VCE over RL, or RC, I'm sorry, this is RC, divided by beta. So in other words, this is VCC minus VCE divided by beta RC. Okay? And so, excellent. So that gives us now what is IB, the current right here, based on elements that are on the right-hand side of the circuit. This here is based on elements that are on the left-hand side of the circuit. So having established these equations, hopefully they will help you solve problems depending on how they are proposed to you.